Hi. If brevity is the soul of wit, then the soul of JavaScript must be timing. And today we'll be investigating some aspects of JavaScript that involve timing. We'll look at set timeout, the queue promises library, and we'll touch very briefly on futures and fibers as implemented by the fibers npm package as well as Meteor. If you've done JavaScript programming for a while, then you've done Ajax. And if you've done Ajax, you've dealt with asynchronous programming. And you might know that from the jQuery.ajax method, where you can call it with a URL, pass a callback, in this case before send, but sometimes there would be a completed callback, and the invocation of Ajax would invoke that action asynchronously, in other words, at a later time when the request completes. But you might not be familiar with this version of this where you chain onto the return value from .ajax. You invoke methods on it like done and pass them the callback. So this subtle distinction actually means that you can use the return value from .ajax before it has completed, and you can do things with that return value. So let's explore these concepts a little. This important distinction has some very cool consequences in JavaScript. So let's look at what this code does when it runs. I'll explain it in just a second, but if you want to skim it and hazard a guess as to what it does, I'll let you ponder this for a second. And it turns out that when we run it, the following happens. 3 requests are fired off. Bitlify this, bitlify that, bitlify this. And they come back at a later time, somewhat randomized. They could come back in the same order, but in this case they did not. And all the while that you're waiting for these responses, you see that the program is still running. It's not hung, it's not blocked. In fact, if it were blocked, you wouldn't have been able to fire off requests 2 and 3. Okay, so in JavaScript, it's not too hard to achieve something like this. And here's the code. It'll be in CoffeeScript, but that's because it's fewer characters to express function. I don't have to say function return. And since we're doing that a lot, it's a lot more concise. So in this code, we pull in some libraries. We define a custom print message to put decorations around the message. And then we set up a ticker to show we're not blocked. So print dot is a function, that's what this arrow means, that writes a dot to standard out. And we ask JavaScript to schedule this function print dot every 100 milliseconds. So 10 times a second is the interval at which we're seeing these dots. So there's effectively no time between requests A, B, C starting, but then there is time between their completions. Lastly, we take a few arguments on the command line. You can see this is the exact command line. So we're just asking for the arguments in these positions here, and then we have the files. Now, the process of bitlifying, in the real world, we would go to the Bitly API. In our example, what we're doing is saying this. Bitlify is a function that takes a path and a callback. And this function, right, here's the function body underneath the arrow and indented. It's going to print a message when it begins bitlifying. And then it's going to set a timeout to a function that prints the supposed return value, right? We'll just kind of hard code it, and then invokes the callback with that same return value. Okay, so this is like the Ajax invocation accepting a callback, and that callback will be invoked with the data that was returned. So bitlify will also take a somewhat random amount of time to occur, and then when we run this file, using the command line CoffeeScript runner, which runs Node.js. It defines a main function for file and files, bitlify the file, and print a dot. We don't really need to print a dot after we bitlify the file, but why not? And then we invoke the main function that was so defined. All right, so as a result, we see the consequences that we just saw. But there's a problem with this. One, you notice this program just ran forever. Well, the reason it had to do that is because we had no idea when the last request was done. So we just can't tell when we fire off these set timeouts to some point in the future. There's just no way for us to be notified when all of them are done. At least there's no way to do that usually without entering into callback hell. So I'm going to introduce the promises version of doing this that is a little more desirable. So as I indicated, without using promises, it's not possible to get the return value for all of these in one object. So for example, an array. In other words, you can't map the bitlify function over this array because it's asynchronous. You'll never know when you have the completed array. But using promises, that's not a problem. So you see in this example, the same initial behavior and then the same results coming back after a random amount of time. But then you see an array with the combined results. So how do you think we did that? When you use promises, it's not too hard. But let me show you the changes of code from the promise version to the no promise version. Okay, so in order to make this the promises version that allowed us to get the arrays, the array of results, we have to do a few things. We require a library called Q. We define bitlify, but we don't define it to take a callback anymore, okay? We define it instead, very similarly, but instead of taking a callback, we return a promise. So you don't need the return keyword in CoffeeScript, but this function has one expression nested under it, and it's a promise. That promise invokes, it gives you, when it is created, access to a resolve callback and a reject callback. The resolve callback is something that your code will call when it has an answer. The reject callback is something your code will call when there's an exception. And the promises library will take care of both exceptions and good results. So instead of passing the new URL to a callback, we pass it to the resolve method that Q gives us. Now, what's interesting is on the bottom. Well, now we in fact can map bitlify over all the files. Now what does that return? It returns an array of promises. And an array of promises can be given to q.all. Q.all accepts an array of promises and returns a single promise which only is resolved, right? So it calls its resolve method when all of the promises resolve. And so to the promise returned by q.all, you are attaching a done callback to console dir the array. That's just a nice pretty printer, console dir. And then exit the process. So you notice that this one was able to exit itself because it knew when all of the bitly requests were done. So that is a beautiful thing that you can do with promises. You can essentially await an array of them, and that would have been hard to do with set timeout. So that's one of the dimensions of programming with promises that feels a bit like you're reaching into the future for a